Alright, in this video I'm going to show how to make a ray diagram for a convex mirror. That means it's convex as in it's fat in the middle, it doesn't cave in, so convex is the opposite of that, with an object that's far away. For this we're going to do the same three rays that we do. The first two will locate our image and then the third one will just confirm it. Ray number one goes parallel to the optic axis and then bends through the focal point. Now you're going to notice with this mirror that the rays actually diverge. They actually all bend away from each other, which means there's no such thing as a real focal point. But if we take all those divergent rays and we extend them, then we can get this imaginary focal point back here. And so when I do this ray, I'm going to do it so that it goes parallel, and then I'm going to extend from the focal point away so I can see where the ray would have gone had it been able to go through. So here we go. It comes in parallel. And now I said I bend through the focal point, but obviously the ray can't go through the mirror and come down to this focal point. So for this part, I'm going to take the ray from the focal point and take it away. So that shows how that ray would bend off of the mirror into that diverging ray that we would expect. Our second ray again is the same as our standard second ray here. We're going to come in headed towards the focal point and then we're going to bend parallel. So again, I'm going to head in here, trying to get to the focal point. I'm not going to be able to get there, so I'm just going to back that off to the mirror. So I'm headed towards the focal point, but not quite getting there. And then my ray is going to get reflected away like this, parallel. Okay. Now what I can see here is I have two divergent rays. They're never going to meet with each other, they're headed away from each other. So what I need to do is I need to extend both rays so that I can see where they would meet if my eye assumed that the light was traveling in straight lines and so made up a virtual image where it appears that this object is located. So for ray number one, I've already extended it right here. This line should be dotted if I was doing this ray diagram properly, and I'm going to fix that. Actually, I might as well fix that right now. Let's just get a hold of that thing. Oh, that's not what I wanted. Oh, how do I do this? I'm getting all kinds of funny things here. Hold on. I'll get my eraser. There we go. That'll do it. So I'm just going to take that out, and I'm going to replace it with a ray. Oh, see, I'm still on highlight here. Hold on a second here. I want to go on pen, and then a ray. That was... What am I doing here? I must have missed... There we go. Sorry about that. There we go. Now this should work. Yep, there's my ray. So that's my real light. And then for the other ones, I should be using dotted lines. So I'm just going to do it the old-fashioned way here. So dotted line towards that focal point and extending that one with a dotted line. And what I can see here is that my image would be formed right here. So again, the primary ray comes in parallel and in line with the focal point, bends away. It's a convex mirror. There's no real focal point here, just a virtual one behind it. The second ray comes in as if it's headed towards the focal point and bends parallel. Those two rays are never going to meet each other. They're clearly moving away from each other. So if I extend them backwards, I can find out where my eye, which assumes that light travels in straight lines, would have assumed that they had intersected. And I get this little image here. This image is small, it's upright, it's close to the mirror, and it is virtual. There's no real light coming together to form that image, and so it's a virtual image. I can still do my third ray to confirm my ray diagram. Again, that's the ray that's going to head towards the center of curvature and bounce straight off of the mirror. So that ray would start here, headed towards the center of curvature, and we can see that it's going to head through the top of where I've located the image, or pretty close to where I want it to right there. And so we can say that that third ray confirms the location of that image, and that's that. So again, with a convex mirror, we have a virtual focal point behind the mirror. There's its center of curvature. If I extended this big circle, that's where the center of that circle would be. I do my two rays, my ray coming in parallel that bounces off as if it would have tried to go through the focal point. My ray that's headed towards that focal point but hits the mirror and bounces off parallel. I see the connection or the intersection of those two rays. Since the two real rays are headed off, separating for each other, I know that there's no real image here. They never really form an intersection point. So I work backwards to say, if they were straight lines, where would they have intersected? Since it's not real light there, I can see that it's a virtual image. Obviously it's small, upright, and close. And then my third ray, which comes from the top of my object, headed towards my center of curvature, and bounces straight back on itself, should line up with the top of that image, and if it does, then that confirms the location of that image. So that is a convex mirror with an object that's far away. Oops, I obviously have a typo there. Away is what I meant.